Hello, welcome to the session on arrays. In this module, we study about one of the most commonly used data structures, that is array. An array is a collection of data and all these data elements are of homogeneous type. The data in an array is stored in continuous locations. Each of the data in an array is stored in a specific position. The position of the data in an array is also called as the index. Storing of the data in an array can be compared to storage of books of the same size in a shelf with no space between each of these books. An array is shown in the slide in front of you. There are totally 5 elements and each of these elements are stored continuously. And if you observe, all these elements are of integer type. The position for the storage of the array elements starts from 0 and goes up till 4. So, 0th position represents the first element and the 4th position represents the place for the last element. Properties of the arrays. The elements of the array can be accessed in any random order because we know the specific position of the data elements in an array. So which means knowing the position, we can access the elements of the array. For example, if we need to access the third element, we use the index or the position 2. And similarly, if we want to access the last element in the array, we can use the index 4 and access the element. There are 3 basic operations that we can perform in an array. The first operation being reading the elements of an array. We have already discussed about it. Because we know the position of the data elements in an array, it is easy to read the value or it is easy to read the data elements of an array by knowing the position of these data elements. The second operation is inserting a value into an array. What is important to note while inserting an element in an array is that the size of the array should be adequate enough to insert the new element into the array. The last operation we can think about is deleting the array element. Now let's look at the insertion of an element in an array with an illustration. As shown in the figure, we have an array comprising of 3 elements, 3, 10 and 6. The data element positions are 0, 1 and 2. This array needs to be inserted with a new element at position 3. So now we should ensure that the array should have space to insert the new element, and also we are considering a situation where the insertion of the data element in an array happens to be at the last position. There are 2 steps involved while I actually insert the array. One is to identify the position where the array element has to be inserted, and the second one is to copy the element into the respective position. As you can see here, we have to insert the element 7 and at the position 3. So we have identified the array index position 3 and simply we copy that element 7 into position 3. Hence, the array which was initially comprising of 3 elements has got one insertion, that is element 7 being inserted, and the size of the array has grown from data elements 3 to the data elements 4. That is, the size is increased from 3 to 4. We can also look at inserting the element into an array at the mid of the array position. Let's consider a situation where an element 7 has to be inserted in the mid of the array, that is at the position 1. In this case, we need to shift the elements 6 and 10 to the next index position so that we make space for inserting the new element. Once the space is created, we copy the new element, that is 7, into the respective position. The illustration of this is shown in the slide. So now element 7 has been inserted into the vacant space that got created at the position 1, and this position was created by moving the elements 10 and 6 to the position 2 and 3. The new array is shown in the slide. Now let's consider the last operation, that is deleting the element in an array. Again, let's consider the situation where we delete the last element in an array. There are two steps involved again in this case. First one is to identify the position or the index value for the last element, and second step is simply to remove that element. Consider this example wherein we have totally 5 elements and we need to delete the element 12. The position where 12 is present is 4. So we identify 4, which is the index of the last element, and simply delete that element. This will result in the new array as shown in the figure, with 12, which was the last data element in position 4, being deleted. Let's now consider the situation wherein we need to delete an element in an array from the mid position. Let us consider the index position where the element has to be deleted is 2. There are two steps again involved here. First, you remove the element from the index 2 and then shift all the elements, that is 7 and 12, which was present initially to the right of the index 2. Now we have to shift it to the left so that there is no vacant space or a hole created between the two data elements. As you can see in this diagram, initially 3, 10, 6, 7, 12 are the elements. We need to delete the element 6 present in index 2. We delete the element and subsequently we move the data element 7 and 12 into position 2 and 3. This will result in the new array as shown in the diagram. So with this, we conclude the discussion on arrays. Quickly to summarize, an array is one of the most commonly used data structure and is used when we need a faster retrieval of the data in a very random way. Array is not a preferred data structure if the size of the data is increasing dynamically. Also, array may not be preferred